Hi, AP. This is section 2 of chapter 6. This is going to cover the concepts of enthalpy, energy, and calorimetry. And technically speaking, enthalpy, which we designate with an H, and energy, which we designate with an E, they're pretty much the same thing. So you'll find me flittering back and forth between enthalpy, energy, and stuff like that. But we're going to be this guy. You'll see this guy most. You just saw internal energy. You remember internal energy was Q plus W. So this guy's the one we're going to do when we do stoichiometry, when we do Hess's law, when we do calorimetry, and when we do, there's another one that I am forgetting, when we do heat of formation. So this is the one we're going to use most. And this is the one you saw first year chemistry. And this one you were just experiencing in the last video. Section 2's got like 3-4 parts, so this is technically part 1. We're off to the races. Enthalpy is the measure of energy flow as heat. The change in enthalpy of a system has no easily interpreted meaning except at constant pressure, where the change in enthalpy will be equal to heat. Oh, what a lot of gobbledygook. Want to know the bottom line? This guy here will technically be equal to the heat exchanged of a reaction at constant pressure. And this is the one we are going to come across more frequently. Energy, which you had in the last video, is the capacity to do work or produce heat. And change of energy you already worked with in the last video. And bottom line is that we will find out shortly that the change in energy is equal to the heat exchange at constant volume. And we do not do this second one very much because we are always standing in a room that is at approximately 1 atmosphere. We are always standing in a room that is approximately 1 atmosphere, so it is always constant pressure. And this guy requires a real fancy smancy bomb calorimeter, so we are going to use this guy more frequently than him. What are you measuring when you measure heat in a calorimeter? And of course our calorimeters are technically, if you recall from first year chemistry, are stacked styrofoam cups. Because of course, what is a very good heat insulator but a styrofoam cup? I mean, think about it. What do you get your tea or your coffee in? Styrofoam cups. Why? Because they keep the heat from escaping from the coffee or the tea. It depends on the conditions. Are we doing calorimetry at constant pressure or constant volume? And in the class, it'll always be at constant pressure. Because for us, we are using calorimeters, which are stacked styrofoam coffee cups, at constant pressure. There's our fancy coffee cup calorimeter, and it measures heat at constant pressure. And enthalpy is just designated with an H. Change in enthalpy is designated with the little triangular thing at constant pressure. Alright, so let's see how this works. Well, let's see. enthalpy is going to be energy plus P times V, which of course you're already familiar with. It's really hard to find the exact enthalpy of a system, so we find the change in enthalpy. And at constant pressure, which is no change in pressure, it becomes change in enthalpy being equal to the change in internal energy plus pressure, whatever the constant pressure is, and change of volume. This technically becomes and it changes to and since work then it becomes and what cancels out. So of course all the math's going to cancel out, and what are you left with? You're left with enthalpy will be heat at constant pressure. And that's what we're going to use all the time. Enthalpy. A bomb calorimeter measures the heat flow at a constant volume. The volume is that steel walled thingy in the center. So the volume will not change. So this is going to be at constant volume. The reaction occurs in a very rigid container. So if it's a very rigid container, the volume can't change. There's no work done. Because again, work is of course change in volume. Well, if there's no change in volume, there's no work. It's just heat. And it's not even a heat transfer. It's just a creation of. So at constant volume, Q is a measure of the energy change. And this one we're not going to use as much as the previous one. Alright, so let's see how this works. We already did internal energy. In a bomb calorimeter, since the volume is constant, then the work will be 0, and that's nice and simple, isn't it? So at constant volume, the change in internal energy is going to be heat, and it's not a transfer. Of heat, but a production of. Bottom line, how hard does this get? Gets no harder than just remembering that really we're enthalpy. At enthalpy, energy is transferred at constant pressure, and at constant volume, energy is being produced.